So your test tomorrow goes over sections they should be 4.1 to 4.3. However, we haven't been calling them, so it's just solving systems. The only thing that you're not going to see on your review that is on your test, which was also on your quiz, is whether or not a given ordered pair is a solution to the system. When those are the questions that you get, make sure you plug in your x for x, your y for y in both equations. If you get a true statement for both, then you know that it's a solution. If you get a false statement for both, or one, then it's not a solution. The first two questions that we're looking at, we are solving the system by graphing. For number 1, it gives you negative 5x plus y is equal to negative 5. For this one, we're just getting y by itself. So we're going to move the negative 5x over by adding it to both sides. So we're going to do negative 5x plus y is equal to negative 5. We're going to add the 5 over, or the 5x over, sorry. And we have y is equal to 5x minus 5. So from here, our slope is 5. So we're going to go up 5 to the right 1. And our b is negative 5, giving us a y-intercept of 0, negative 5. So to plot these, or this line, 1, 2, 3, 4, 5, the 0, negative 5 would be on your y-axis at negative 5. Then from there, we're going up 5 into the right 1. Up 5 to the right 1. The other equation that you have is the negative 4x plus 2y is equal to 2. For this one, we're just going to solve it for y. So we're going to add the 4x over. This gives you 2y is equal to 4x plus 2. Then we divide each side by the 2. And you have that y is 2x plus 1. So for this one, our slope is 2, which means we're going up 2 to the right 1. And our b is 1, so we're starting at 0, 1. So 0, 1 is here. We go up 2 to the right 1, up 2 to the right 1. We're going to have a line that looks similar to this. So the point where these two intersect or cross is where our solution is. So in this case, it is 2, 5. For number 2, you have y is equal to 2x minus 3, and y is equal to negative x plus 3. For the y is equal to 2x minus 3, your slope is 2. So we're going to go up 2 to the right 1. And your b is negative 3. So that means we're going to start at the ordered pair 0, negative 3. So 0, negative 3 is here. We're going to go up 2 to the right 1. And draw our line through those points. For the y is equal to negative x plus 3, your slope is negative 1. So we're going to go down 1 to the right 1. Your b is 3, so we're going to start at 0, 3. 1, 2, 3, 0, 3 is here. Down 1 to the right 1 gives us this line. So again, the point at which these two lines cross at is your solution. So in this case, this is 2, 1. For the next section of questions, you're solving each system using substitution. For 3, you have y is equal to x plus 6, and y is equal to negative 2x minus 3. Since both of these are y is equal to, we're going to take the expressions that they're equal to and set them equal to one another and solve for x. So this is going to give us x plus 6 is equal to negative 2x minus 3. We can move the 2x over by adding it to both sides. So this is going to be 3x plus 6 is equal to negative 3. We're going to subtract the 6 from each side. And this is going to give us 3x is equal to negative 9. From here, we're going to divide each side by the 3, and we get that x is negative 3. If we have that x is negative 3, which of the two did you want to substitute the negative 3 into, the top or the bottom? You want to do the top. So y is equal to x, which is negative 3 plus 6. The negative 3 plus 6 gives us positive 3. So this is just negative 3, 3. For number 4, you have y is equal to 4x plus 6 and y is equal to 2x. We're going to set these both equal to one another once again. So it's just going to be 4x plus 6 is equal to 2x. The 4x we're going to move over, subtract it from each side. This gives us 6 is equal to negative 2x. And we divide each side by the negative 2 and get that x is negative 3. If we plug that negative 3 in, which would you like to use, the top or the bottom? Bottom. So it's going to be y is equal to 2 times x, which is negative 3. So y is equal to negative 6. So if x is negative 3, y is negative 6. That gives us the solution of negative 3, negative 6. For number 5, we have 3x plus 2y is equal to 7, and y is equal to negative 3x plus 11. We're going to take the negative 3x plus 11 and plug it in for y in that top equation. So we're going to have 3x plus 2 times negative 3x plus 11 is equal to 7. From here, we're going to distribute that 2 in. So 3x minus 6x plus 22 is equal to 7. The 3 minus 6x is negative 3x plus 22 is equal to 7. We subtract the 22 from both sides, and we get negative 3x is equal to negative 15. So we divide each side by the negative 3, and we have that x is 5. If x is 5, we can plug it into that bottom equation and solve for y by just doing y is equal to negative 3 times 5 plus 11. The negative 3 times 5 gives us negative 15, plus 11 gives us a y of negative 4. So if x is 5, y is negative 4, it gives us 5, negative 4 for our solution. For number 6, you have 4x plus 3y is equal to 11. And 3x plus 2y is equal to 8. For this one, I'm going to move down below this example, or not the example, the instructions for the next section, and do this one out. I would take the bottom equation, that 3x plus 2y is equal to 8, and solve it for the y. By doing so, I would subtract the 3x from both sides. That would give us 2y is equal to negative 3x plus 8. And then divide each side by the 2 to get y is equal to negative 3 over 2x plus 4. If I use this and plug it into the top equation, it's going to give us 4x plus 3 times negative 3 over 2x plus 4 is equal to 11. We can distribute the 3 in, so that gives us 4x plus negative 9 over 2, so minus 9 over 2x plus 12 is equal to 11. We can rewrite this 4x as 8 over 2x, so that way we can subtract those fractions. And then from here, we just have to combine like terms, which gives us negative 1/2 x plus 12 is equal to 11. We can move the 12 over by subtracting it from each side. So that's negative 1/2 x is equal to negative 1. And then we're going to divide each side by that negative 1/2, which is the same thing as multiplying by the reciprocal. So just like multiplying by negative 2. So the negative 1 times the negative 2 gives us a positive 2 for x. We're going to solve for y now by using the y is equal to negative 3 over 2x plus 4. So if we plug that 2 in for x there, that's going to give us y is equal to negative 3 over 2 times 2 plus 4, which is y is equal to negative 3 plus 4. So y is equal to 1. If x is 2, y is 1, that gives us our solution of 2, 1. The last part of your review goes over solving these systems using elimination. So if we look at number 7, we have 2x minus 2y is equal to negative 8, and x plus 2y is equal to negative 1. You'll realize here that your y's have opposite coefficients, which means if you added these two, they would cancel the y's out. So we're going to just add these. Those y's would cancel. The 2x plus x is 3x, and the negative 8 minus 1 is negative 9. If we divide each side by the 3, we get that x is negative 3. So I'm going to use the bottom equation with x plus 2y is equal to negative 1, and plug in that negative 3 for x. So it's going to give us negative 3 plus 2y is equal to negative 1. We add the 3 over. We get 2y is equal to 2. And we divide each side by the 2 and get that y is 1. So if x is negative 3 and y is 1, our solution for this one is just negative 3, 1. For number 8, you have 3x minus 4y is equal to negative 24, and x plus y is equal to negative 1. If it was me, I would multiply the bottom equation by negative 3, so that way it cancels out my x values. So this is going to give us 3x minus 4y is equal to negative 24, as well as negative 3x minus 3y is equal to positive 3. From here, I can add these, and my x's will cancel since they have opposite coefficients. That negative 4y minus 3y is negative 7y, and the negative 24 plus 3 gives us negative 21. From here, we'll divide each side by the negative 7 to get y is 3. Take the 3, plug it into one of the original equations. If it was up to me, I'd use the bottom one. So it's going to give us x plus 3 is equal to negative 1. We move the 3 over by subtracting it from each side, and we get that x is equal to negative 4. So if x is negative 4, y is 3, it gives us the ordered pair of negative 4, 3. For number 9, you have x plus 2y is equal to negative 6, and 3x plus 8y is equal to negative 20. If we multiply the top equation by negative 3, it will cancel out our x values. So this is going to give us negative 3x minus 6y is equal to 18, as well as 3x plus 8y is equal to negative 20. So from here, we can add them. Those x's cancel. We get 2y is equal to negative 2. We divide each side by the 2 and get that y is negative 1. To solve for x, I would use the top equation. We get x plus 2 times negative 1 is equal to negative 6. The 2 times negative 1 is negative 2. So that's x minus 2 is equal to negative 6. We add that 2 over and get that x is negative 4. So if x is negative 4, y is negative 1. That gives us negative 4, negative 1. For number 10, you have negative 2 over 7x minus 4 over 3y is equal to 8, as well as 4 over 7x plus 8 over 3y is equal to negative 16. If you don't like working with your fractions, get rid of them. multiply each equation by its least common denominator. So with the top one, your least common denominator is 21. So I'd multiply the whole equation by 21. Bottom, same thing. If you don't want to work with the fractions, multiply the whole thing by 21. If you are okay with working with the fractions, the top equation, your x's are opposites, your y's are opposites. However, the coefficients are not the same. So, in order to make the 2 over 7 a 4 over 7, with your x, we would multiply it by 2. So you can multiply the top equation by 2, and this would give you negative 4 over 7x minus 8 over 3y is equal to 16, as well as 4 over 7x plus 8 over 3y is equal to negative 16. We're going to add these. Your x's cancel, which gives you which gives you 0 on the left side because your y's cancel as well. Your 16s also cancel, which gives you 0 on the right side. You have 0 is equal to 0. This is a true statement. So because this is a true statement, your answer for something like this is infinitely many solutions. If you were to get a false statement, so something like 0 is equal to, let's say, 8, it would be a false statement, which means your answer would be no solutions. Once again, the only thing that is not on your review that you will see on your test is stating whether or not an ordered pair is a solution to the system. So remember, with those, plug in your x for x, plug in your y for y. If either of the two equations give you a false statement, it is not a solution. If they give you true statements for both, the ordered pair is a solution.